It's like, oh man. All right.
Smile at the camera.
So, we are now going to flip over to your notes to page 26, I believe, is the beginning of this lesson. Today we're going to talk about not just what happens between, like we kind of did yesterday with continuity, like what's happening, but we're going to talk now about the ends of our graph, something called end behavior. So literally how the end of your graph behaves. And we're going to learn how to describe that and a little bit of new notation. So can I get someone to read for me up here where it says the end behavior? Go for it.
The end behaviors of a function describes how a function behaves at either end of the graph. That is, end behavior is what happens to the values of f of s as x increases and increases without bounds, becoming greater and greater or more negative. Describe the end behavior of a graph. It means the concept of the limit.
Okay. So key things here. We are describing the end behavior, how the end of the graph behaves. And we are going to be doing it by not just like verbally saying it does this. We're going to be using some notation that we call a limit. This is probably the first time you have ever seen limit notation. We will have a whole like section at the end of the year on limits. And limits are going to then be a huge part of calculus. I know even right now they're doing unit 1. Is limits. I know that I think Miss Sloan, they just had their first quiz on limits. And so you might have seen, if you see your friends in calc or in pre-cal last year with this thing that says like LIM and it has like a bunch of stuff going on. We're going to learn right now what this notation means, and we're going to use it today for the purpose of end behavior. Okay? This is your first intro to limits, and then from here on out, limits will be your best friend. All right, so let's talk about the left end of the behavior, how we, instead of just saying on the left side, how we write that with limits, okay? You're going to say LIM, that stands for the limit, as, like in words, we'd say the limit as x. We're going to talk about something happening to x, and then we're going to talk about what happens to our function, what happens to the y values. As x, if we're talking about the left side of our graph, think about it. If we get further and further and further to the left side of our graph, what's happening to the x values? Messiah? They're decreasing. The x values are going towards, we can say, negative infinity, right? They're going towards that side of the number line, negative infinity. We're talking about some graph of a function f of x, okay, equals, and then this is where we're going to actually write what happens on the left side, like what is happening to our y values. So this is the notation to basically say, using limits, like on the left side of your graph, blah is happening. Like this is how we say it in limits. Let me translate it one more time. It means the limit as x goes to negative infinity, because that's the left, right, of our function is doing something, and we're going to describe what it's doing, okay? So this is our first notation. This is for the left side of the graph. For the right side of our graph, we're going to take a limit. This time, who thinks they've got it? We're on the right side. What do you think we're going to write the limit as what is happening? Yep. Christina? As
It's going to positive infinity.
woo, x is going to positive infinity. So you can write the little plus sign, or you can just leave it because when something doesn't have a sign, it's positive. So positive infinity of our function f of x equals something else. So then we're going to talk about what's going on that side. So all we're doing right now, we're not really like solving anything or doing anything. We're just getting down the notation of how we say the left side and the right side of our graph. Okay? Okay, let's look at this example to see like the answer, what could happen there now, okay? Looking at this graph, how would you describe to me, in your own words, on the left side of our graph, this side of our graph, in your own words, let's not worry about limit notation, how would you describe to me what's happening on that side of the graph to the y values? Where are the y values headed? Oh yeah, we could just shout out. What do you think? Up, positive. So in math, we would call that up, positive. We call that positive infinity, right? Because it's just up is big numbers, right? Like infinity. So we could say, I know this is kind of small, so I'll write it a little bigger. The limit as x goes to negative infinity of f of x. What does this mean to us? It's just the left side of the graph, right?
Yeah.
You're saying on the left side of the graph, what's happening to y? Melanie just said it's going to infinity. The y's are going up to infinity. As the x's are going to negative infinity, going back, our y's are going up to positive infinity. Okay? Let's look at the other side of our graph. On the right side of our graph, in your words, raise your hand this time so I can give someone a stamp. And I know who's talking. Who could describe to me what they think is happening on the right side of our graph? Eli?
Maybe like negative infinity.
Negative infinity. So on the other side of our graph, we're going down, as Melanie would say, to negative infinity. So the limit as x goes to infinity. Why did I write infinity here if you said negative infinity? Christina?
It's further left than the right.
Because this is telling me like the right side of my graph, right? It's not talking about where like the arrow is going. It's talking about the right side of my graph. I'm going, like Eli said, to negative infinity. Right side, I'm going to negative infinity. Left side, I'm going to positive infinity. Okay? So this is the proper notation. There's your end behavior is your answer. Question?
So every time for the equal sign, we have to check the y.
So this right here, I love that. You could write that in your notes if you want to. This, whatever goes in this box, like our answer, is describing what's happening to the y values because you're describing what happens to f of x, which is like your output, your function, your y values, right? Cool? So you're thinking what's happening to my y values, they're going up, they're going down, okay? So that's what this paragraph basically says right here. One possibility, I'm going to talk about some other possibilities, but one possibility is for the end behavior of a graph of a function to increase or decrease without bound. It's not like tied down, it's going up forever or down forever. Infinity, negative infinity. Okay? That would be a case like this. So one possibility is like both sides could be going up. Another possibility, both sides could be going down. You could have like this. One side going up and one side going down, or it could be the other way, right? Or, yeah, I saw even Melanie was like, if it's like this, that's like a parabola would have positive infinity. If it doesn't increase without bound or decrease without bound, it could also like level out somewhere in between and approach a horizontal asymptote. So towards the end of class, we're going to talk about also how these answers don't have to be infinities. They can also be numbers if we level out at an actual value. Yep?
What about x cubed?
Oh, x cubed is a parent function. Looks kind of like this, but like that. Okay? So the...
What about, never mind.
Oh.
Sorry, I mean the ones that go like this,
Oh.
like the side ones. I don't know which ones are those, but I thought
The weird
I
ones.
like your question.
Turbulent.
This, okay, this is not a function, f of x. Who remembers why this example is not a function? So we're not going to do this because we can't say the limit of f of x. Why is this not a function? I think I owe some stamps to some people. I'm going to come give them in a second. I know I'm coming. Kennedy, why is this not a function? Perfect. It has two y values for one x value. So this is not an f of x anyways, and so we're good. Cool? So you shouldn't have it look like that. Yeah? Great question. I'm coming for your question. Stamp, Kennedy, for your answer. I'll be there in a second. Giselle will be there in a second. All right. Let's look at this example right here. Take a look at the graph. I was gonna have someone read this, but I don't want someone to like struggle through reading that polynomial. So use the graph of f of x. I'm not gonna read that whole thing to describe its end behavior, which means ding 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 ding. Everyone underline where it says describe its end behavior. At this point, especially like this week, we have learned a lot of content. Every day has been like a full-on lesson. I want you to like really be paying attention to direction so you know like what we're doing. I don't want you to read this and be like, am I trying to do like that 1, 2, 3 continuity test thing? Like that is the continuity test. So if the directions say to prove whether something's continuous or discontinuous, you're in that like land of doing step 1, 2, 3. When you see describe end behavior, I want you to like light bulb to go off in your head and you say, hey, that's talking about the left side and the right side, which mean I need to write two different limits. That notation we just learned. Describe end behavior means I need to write two different limits and then decide what's happening on either side of my graph. One of the limits, x is going to negative infinity. Which side is that? Left. One of the limits, x is going to positive infinity. So let's talk about the right of our graph. Okay? Describe the end behavior. That is what we are doing. Okay. Let's describe it. I see the graph. Here it is. Really quickly, turn and talk with your neighbors about what you think is happening on either side of the graph and where it's headed. Turn and talk 10 seconds. Turn and talk. Which one? Where's it going? Share. See what you think. Alrighty. Juan Carlos, coming to you. What's happening on the left side of our graph? Where is it headed? Negative infinity, I agree with you. Down, 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 down. Okay. On the right side of our graph, Juan Carlos, I don't know, what call on someone else. Edith, you chose it. Negative infinity. Alright, cool? Okay. Sometimes, like, the way I explain one thing might work for some of y'all, but other people's brains might work kind of differently. So, right here, for the purpose of today, I'm not going to have all of us fill out this table, but we could also support our answer by examining, like, individual values as we get closer and closer and closer, like, towards negative infinity to the x's, and towards positive infinity on the other side, and we could look at what's happening to those values. This is kind of like using the trace tool that we just used on our calculator. Like we could find different points along the way. So if you like this better, let's kind of just like support our answer. Again, you don't have to copy all this down, but I'm just showing you, okay? If our x values get increasingly negative, negative 100, negative 1,000, negative 10,000. What do you notice? I plugged them into our function, and I got these crazy numbers. Like this one is negative 1 times 10 to the 16. That means like negative 1, 0, 0, 0. I'm not even going to write them all because I don't want to. That's a really, really, really negative number, which is kind of numerically showing you that we're going down to negative infinity, really negative numbers. Cool. On this side, when I plugged in 100 and then 1,000 and then 10,000, either using my trace tool or by hand, same thing. Look, I'm like way out here at negative 1 million, bajillion, something. Okay? So I'm getting really, really negative on either side. So if that helps you more like conceptually understand what's going on, if the graph, like the picture is not doing it for you, maybe that helps. But you don't have to, again, I'm going to move on. You don't need to write down the whole table. Okay? Okay. Moving on. One more to kind of get started on together, and then you're going to practice a couple. We got another graph, another function. So again, notice, kind of like Brian's question, All these are functions, they all pass the vertical line test. We want to describe its end behavior. Tyler, what do you think then we should write down first when we see those instructions? The limits, because we want that's how we're going to describe our end behavior. We are in pre-cal, and so we are going to use limit notation rather than just saying left and right side. Okay. We said some graphs go up, some graphs go down, some graphs go up on a side and down on another side, and then remember I said some graphs like level off in between. Okay. Take a look at this graph. What do you notice about the left and right side? Just making some observations to start out with. Gustavo, what do you notice is happening with the left and right? Just in your own words. You don't have to give me a final answer yet. It's like straight leveling off somewhere. So now what we have to figure out is what value, like what y value are we leveling off at? Which means we're approaching like a horizontal asymptote. So we've got to figure out if I were to take something horizontal, I have a pencil, are they approaching negative 0.8? No, so like we're trying to figure out where is it approaching my pencil. And it would be probably somewhere like right here, right? It's approaching the pencil. Up here it's like too high, right here. This one's like past it up, right? Whatever. So yeah, what y value is right here? 0. So it's approaching 0 on this side and 0 on the other side. Notice that I said approaching. Picture like yourself on a little bicycle riding along the graph on the left side. It's like you're riding your bicycle and you're trying to describe what you're headed towards, but you're not actually going to get there. So if you would have said like, oh, I think it's headed towards point 2, and then you look close, like actually you passed up point 2, so you're not headed to point 2, you passed it up, and like you're trying to guess where it's going, okay? And it won't actually get there, okay? Do these two things have to necessarily both be the same? It was like 0 on both sides in this one?
No.
No, so be careful. It could like level off here and then like level off here, so we might be looking for two different things. Or one could level off and one could go to infinity, okay? So you gotta look at both sides separately. Okay. Based off of those examples and that modeling and that dancing, yes, Brian, question, and then we're gonna practice.
So what if it's like a W shape that goes to negative and then it goes to positive again? Like you know how to be W and then no. It's like
Why don't you, or can I get them started and you come draw it and then maybe talk about it when we come back together for time? Okay, you guys, and then we're gonna address it, but I'm not good at translating. I want you all to look at 5A and 5B. If all else fails, look at your instructions and see that it's end behavior and write down your limit notation. And then start to talk about if you and your neighbors can figure out what's happening on either end. Find your answers, okay? I'll give you a few minutes for 5A and 5B, see what you can come up with, then we're coming back together. Come draw. It's Raffle Friday tomorrow.
Okay, so you remember asking folks from last year?
Yes.
It's a line that never touches, so that would be the limit.
We did not hear about any stuff on the inside. We're looking at the ends. This end is going tomorrow we'll talk more about all these like things that go up and down. Increasing versus the graph and decreasing versus the graph. Right now we're just caring about like the tables. Okay? Yep, that part. As far as like our tables.
Actually, I feed her.
Yes, but this is saying x is going to the negative. So picture as these x values go out, and touch on this part of our case. comfortable? Yes, wonderful.
Yeah, that's what I do with infinities.
Slightly below 4. But not, do you think it's, yeah, 3? Because it's not gonna probably, it doesn't look like it's going steep enough, it's just gonna reach 2. So between 2 and 4, it's gonna be 3. But these are, you're just trying to like feel out, sometimes start with the graph to tell exactly where it's headed. So just trust your gut. If you know it's below 4, you can't say 4. What's below 4? Keep them 3. I know. So it looks like it's approaching 4, but notice see how it crosses. You can see that little dotted line. So that means you like actually already passed up. You don't know. So it could be like 3, it could be 3.5. We could look at it like and plug in a bunch of numbers to get a better idea. Technically, I would probably have to grade 3 and 3.5 right because like there's no way of really telling. But in this case, I'll go ahead and tell you like it is hitting 3 like perfectly. If you drew a dotted line, it's approaching that line on both sides. Both of them are going to be approaching 3. One's just approaching from the bottom of the dotted line, one's approaching from the top of the dotted line. Limit, which means like what your how are we doing? And yes, so we're looking at the first, the left side. Let's look at the left side first. This is this one here. Right? Because if you look at like literally this far edge, the left side of your graph, and if you're looking at this arrow, we're trying to describe really just already cycle where we're headed on the left side of our graph. We just passed up 4, right? It doesn't look steep enough to like it's going down, down, down forever. It looks like it's slowing down. If we just passed 4, this would look like slightly below 4. I'm sorry. And it's hard to tell exactly that it's 3, but we're just reasoning here of like how we think.
It's always see and then you use like a intercept.
And this is the right side.
You want? What you want?
Even on.
Yes, you can.
Okay. I probably will not be able to like right now and here to do even on, but I started monitoring lunch. Or if you haven't already, you could try checking out the video for the day to see me do it.
Oh yeah?
Like just through her notes. Do any of those things work for you? Well, what do you think? Just so I can play on the video for now? And then if it doesn't work out, maybe send me an email if it's like started in the weekend and you're like, shoot, I still want to show this is what we do today. And I can like tweak some things. Yes. Few more seconds. So these ones, technically, these guys are you're tracing. See how you're getting and then look, your graph is literally now so you're okay, so if you want line, that's -6, right? And then -6 from the left right? At -6, because even -6 it was this first right after -6. Okay, let me, because that's not this, this. I got 4. I got someone there. Can you wait till Okay. Let's see how we felt when we looked at it on our own. If you can bring it back in the next few seconds.
I want my sister right there.
Bring it back. Finish your conversations. Okay. I'm gonna catch up with y'all because you did a great job as I walked around at least starting with writing down our way of saying the left side and the right side of our graph, which is limit notation. For the left side, x is going negative infinity. For the right side, x is going to positive infinity. Now, the question becomes, where were we going if we were riding along our graph to the left or riding along our graph to the right? Okay. In general, would y'all say it was increasing or decreasing without bound, or was it like leveling off somewhere? Leveling off somewhere. So I see these go up and down, but that's like in the middle of our graph. The end of our graph is this piece and this piece, right? Those are the ends of our graph. That's the left, that's the right. This is like the middle of the graph, right? So let's look at this left side. Somewhat, Melanie, I guess it was like leveling off because this doesn't look like it's headed up or down forever. So the question now becomes, where is it leveling off? So I want to get, let's see, I had a couple people around that had some ideas of where it was leveling off. Brian, you had an idea, right? On this left side, where do we think maybe it's headed? So again, if I use either my pencil, if you like that, or if you want to just like picture I'm riding along and ask yourself what y value you're approaching. 3 would be right here between 2 and 4, right? So if I put my pencil right there at 3, do you guys agree that the arrow looks like it's headed towards 3, but it doesn't quite make it there, right? If you say 4, it already crossed it, so that's like too high up. We clearly passed 4, right? So I'm going to say 3 for that one as well. But Brian made a good point. He's like, how do I know that's exactly the point? It's not like 3.5 or something, and that's hard to tell. But I'm not trying to trick you here, so let's use like simple numbers that if we know it's between 2 and 4, like we're going with 3, okay? On this side, because remember it could be different, let's take a look. If it was at 3, it would be right here. Does it look the same, or do you think it's different? The same, it's just from the bottom side, right? This time it's approaching from the bottom, so we've passed up 2. We're headed towards 3. I don't think it's going to make it all the way up to 4. I think it's going to level off at about 3. But again, you're just going for your reasonable answer here, like when you look at it, what you think. Okay, the one at the bottom. The one at the bottom. Our 2 limits. Who can tell me what they think we're leveling off at about? And I'll go ahead and tell you it's going to be the same on the left and the right. Where does it look like it's leveling off? Brandon, where does it look to you?
-3.
-3. Down here, -3 between -2 and -4. I'd say that's a reasonable, good answer for both sides. Okay? Yeah? Okay. As a closing thought, so it's okay if you're like folding up your paper, but I still want to see kind of eyes and attention here. We do have some assessments starting to come up, like a quiz next week, and then your unit test at the end of the unit. So I just want to show you like an example of how you could ask a problem like this, even on like a multiple choice question. Here is a graph, and I asked, which of the following describes the end behavior? Pause for me. Notice these are your 2 limits written for you. Which way are both of these headed? To positive infinity. So this first answer is positive infinity, positive infinity. This is negative, negative, positive, negative, negative, positive. So it'd be A. So that's like an example of what you should do. Okay? Alright. Bye-bye. Sorry I ran over just a second. Have a great day. And Kennedy, you and I
Thank you guys for watching the video.
Herbalife.
I can't do no sponsoring shit right now, man. I can't sponsor nothing right now. Just
Hey, Kirkwood at 6.
tomorrow.
Tomorrow, still recording.